Much so, how did the girdles get inside the shell, and they're really weird, and how did a turtle get to look like a turtle? It doesn't look like anything else. Okay? And until recently, the oldest turtle fossils, which were just a little bit younger than this, about 210 million years, basically, it had some weird little spines on its head and stuff, but it was basically a turtle. Didn't have teeth, had a shell, girdles inside, it just looked like a turtle. That's where things stood for decades and decades, over a century. Then just a few years ago, this animal was discovered, in China, in the Gobi Desert, deposits in China, an area that's really rich in fossils of all kinds. Odontocheles. Don't worry about the species name, you should be able to recognize the genus. Odontocheles, which means toothed turtle. The species means with half shell. Okay? This animal is dated to about 220 million years ago. This is the most basal turtle. Okay? This is kind of a sort of, the equivalent of Triatobatrachus, the oldest frog, would be the outgroup, would be basal to the clade that includes all living frogs. This animal is basal, the outgroup to all living turtles, the clade that includes all living turtles. Okay? It was found in marine deposits. This is not a sea turtle. Sea turtles are actually very derived, showed up a lot later, 125, 130, 150 million years later. But it was a marine animal, so we know ultimately turtles were derived from marine ancestors. It had teeth, had little teeth, and only the bottom half of the shell, no top of the shell. So this kind of gives us a little bit, and you can see the girdle, the pectoral pelvic is kind of outside the shell. So we know that the bottom of the shell came first, and then the top of the shell formed, in more derived turtle image. It also confirms what we're pretty darn sure about, but actually gives us a date now, a rough date, as to when, a range as to when teeth were lost in the lineage of modern turtles. Here are a few pictures of the fossils. This is a dorsal view, showing the ribs, but we didn't have a dorsal shell yet. Some drawings that was taken from the skull. Little teeth, not big teeth, but there are little teeth in there. Here's a ventral view. The bottom of the shell clearly present. These keratinized plates on the bottom, but no top. A pretty nice fossil specimen. So now those are the turtles. Now we're going to back down to the common ancestor of all the diapsids and go on to another branch, called the lepidosaurs. The lepidosaurs include all living reptiles in the traditional sense. And all I mean by this, in the traditional sense, is birds are not included. Birds are not lepidosaurs. Later on, you'll find out why birds are just highly modified reptiles. But this doesn't include birds, and it does not include crocodilians or turtles. We've already talked about turtles. They're basal to one of the two groups of diapsids. So except crocodilians and turtles and birds. And they include the tuatara, which is not a lizard, but it's kind of a lizard-like looking thing. That's the most basal lineage. And then it includes lizards and snakes, which, as you'll see, are simply very modified lizards. And these things called amphisbaenians. Not amphibians, but amphisbaenians. Weird legless things. So let's talk a little bit about each of these taxa. So the tuatara is in